Good afternoon. Today we're going to learn and understand the properties of matrices with respect to multiplication, and we're going to learn how and when can we multiply two matrices. We learned before about matrices, about adding, subtracting matrices, about scalar product. Today we're going to learn about multiplying matrices. So now let's look at matrix A. As you can see, it is made up of 2 rows and 3 columns. So let's write that down. It is a 2 by 3 matrix. Now if you look at matrix B, you can see that it is made up of 3 rows and 4 columns. So let's write that down as well. It is a 3 by 4 matrix. Now in order to decide if you can multiply those two matrices, if matrix AB exists, you have to look at the column of matrix A and add the row of matrix B. So basically, those inner dimensions should be the same. So since we have A has 3 columns and B has 3 rows, then we can multiply matrix A and B to form a new matrix AB that's going to be a 2 by 4 matrix. And how did we know that? Because it's going to be the row of A and the column of B. 2 by 4. It's a 2 by 4 matrix. Now go ahead and do this example on your own. Please pause the video, take 2 minutes to think about it, and then play it again. Now let's look at matrix C. As you can see, it is made up of 3 rows and it is made up of 2 columns. So let's write that down. It is a 3 by 2 matrix. As for matrix D, it is made up of 1, 2, 3 rows and 1, 2, 3, 4, 5 columns. So it's a 3 by 5 matrix. Now to decide if you can multiply matrix C and D to create matrix CD, the inner dimension should meet or should be the same. So as you can see, this is 2, this is 3. They are not the same, so matrix CD does not exist. And the reason is the inner dimension is not the same. So CD does not exist. Or you can say that matrix CD is not defined. Now let's go ahead and check if we can multiply WX so we can learn how to multiply it. Now let's look at matrix W. It is a 3 by 2 matrix and this is a 2 by 3 matrix. As you can see, the inner dimension is the same. So when you multiply W and X, you're going to create a new matrix called WX, and it will have dimensions 3 by 3. So it's a 3 by 3 matrix, and I get that from the row of W and the column of X. Now let's learn how to multiply W and X. Now as we learned before, we get this 3 from the rows of W. So you have to divide W into rows. And that is 3 rows. And you get this 3 from the columns of X. So let's divide X into 3 columns. Now, when you multiply those two matrices, you're going to create a 3 by 3 matrix, which is WX. So let's prepare it. It's going to be a 3 by 3 matrix. And all of those are going to be numbers that we're going to learn how to calculate now. Now what you should do is you multiply R1, which is row 1 of W, and column 1 of X to create R1C1, which is the number over here. So how do we create that? You go ahead and you multiply the numbers. You multiply 3 by 4, and then you multiply -2 by 5 and add those two numbers. So let's go ahead and do that. 3 times 4 is a 12, plus -2 times 5 is a -10. 12 plus -10 is a 2. So the number over here should be 2. Now what we're gonna do is calculate R1C2, which is R1C2 because it belongs to row 1 and column 2 of WX. We get that from row 1 of W and column 2 of X. So let's go ahead and multiply those two numbers. So you go ahead and multiply 3 by 7 and -2 by 1. Let's do that. 3 times 7 is 21, plus -2 times 1 is a -2. 21 plus -2 is a 19. So number over here is going to be a 19. So go ahead and pause the video to calculate R1C3 on your own. What you should have done is multiply row 1 of W and C3 of X. So let's go ahead and do that. 3 by -2 is a -6, and -2 by -1 is a +2. You add those two numbers. -6 plus 2 is -4. So this number over here is -4. And now you need to multiply row 2 and column 1 to get the number over here. So this number is called row 2, column 1. And it's called row 2, column 1 because it belongs to row 2 of WX and column 1. How do we do that? Just like what we did before, you multiply row 2 of W and column 1 of X. So you multiply 1 by 4 and 0 by 5 to get a 4. So the number over here is a 4. And then to get this number, you multiply row 2 of W and column 2 of X. That's why you get row 2, column 2. And this is going to be R2C2. How do you do that? You multiply 1 by 7 and 0 by 1 to get the number 7. And to get this number, this is row 2C3. So you multiply row 2 by column 3. You multiply 1 by -2 and 0 by -1 to get the number -2. And so on. To get this number over here, as you can see, it is row 3, column 1, which means you have to multiply row 3 of W and column 1 of X. 2 times 4, -1 times 5, and you add those two numbers to get a 3. Now, this number over here is row 3, column 2, and you get it from row 3 of W and column 2 of X. So you multiply 2 by 7, -1 by 1, and you add those two numbers to get 13. This number over here is going to be row 3, column 3, and you get that from row 3 of W and column 3 of X. So you multiply 2 by -2, -1 by -1 to get the number -3. By multiplying matrix W and matrix X, you just created WX. It's a 3 by 3 matrix. So remember, every time you need to multiply two matrices, first of all, you have to check if the inner dimension match. If it does match, then WX is defined, and you multiply it like we were doing over here. Multiplying or dividing W into rows and X into columns. Now on the next two slides, there will be two examples that you should do on your own and present it in class tomorrow to be corrected. Hand it in.